Hello students, welcome back. Let's start our new chapter, Polynomials. Polynomials. Keynotes. An algebraic expression of the form a0 x raised by n plus a1 x raised by n minus 2 plus a2 x raised by n minus 2 plus so on plus an, where a0 plus an, where a0, a1, a2, so on, an are real numbers, n is a non-negative integer, and a0 should not be equal to 0, was called a polynomial of degree n. Degree. The highest power of x in a polynomial p of x is called the polynomial. Polynomial of degree 1, 2, and 3 are called linear, quadratic, and cubic polynomials respectively. There are different types of the polynomials. Constant polynomial. A polynomial of degree 0 is called a constant polynomial, and it is in the form of p of x is equal to k. K can be any constant, 1, 2, 3, so on. Linear polynomial. A polynomial of degree 1 is called a linear polynomial, and it is of the form p of x is equal to ax plus b. This is also known as the general form of linear polynomial, where a, b are real numbers and a should not be equal to 0. Quadratic polynomial. A quadratic polynomial in x with the real coefficients is of the form ax square plus bx plus c, where a, b, c are real numbers with a should not be equal to 0. Was a is the coefficient of x square, b is coefficient of x, and c is a constant term. Cubic polynomial. A polynomial of degree 3 is called a cubic polynomial, and it is in the form of p of x is equal to ax raised by 3 plus bx square plus cx plus d, where a, b, c are real numbers and a should not be equal to 0. Biquadratic polynomial. A polynomial of degree 4 is called a biquadratic polynomial, and it is in the form of p of x is equal to x4, it's ax raised by 4 plus bx cube plus cx square plus dx plus e, where a, b, c, d, e are the real numbers and a should not be equal to 0. The 0 of the polynomial p of x are precisely the x coordinates of the point where the graph of y is equal to p of x intersects the x-axis. That's x is equal to a is 0 polynomial p of x if p of a is equal to 0. A polynomial can have at most the same number of the zeros as the degree of the polynomial. Generally, we can say that a polynomial of degree n has exactly n zeros. For quadratic polynomial, x square plus p of x plus c, where a should not be equal to 0, sum of zeros is always equal to minus b by a, and product of zeros is equal to c by a. The division algorithm states that given any polynomial p of x and polynomial g of x, there are polynomials x and rx, such that p of x is equal to g of x into q of x plus r into x, where g of x should not be equal to 0. Where rx is equal to 0, or degree of rx is always less than the degree of g of x. Find the zeros of each of the following quadratic polynomials and verify the relationship between the zeros and their coefficients. Part A. X square minus 2x minus 8. Solution. How will we find the zeros? We have to use the factorization method. What is factorization method? In factorization method, we have to split the middle term, and the middle term should be split in such a way when we put these terms together, it should become the same term. But when we multiply these two terms, it should become the multiple of first and last term. Now, x square minus 2x minus 8 is equal to 0. X square minus 4x plus 2x minus 8. We split the minus 2x as minus 4x plus 2x. When we subtract minus 4x, it becomes minus 2x. But when we multiply these two terms, it becomes the multiple of first and last term. Now, in x square minus 4x, take x as a common, it becomes x minus 4. And in 2x minus 8, here 2 is a common, it becomes 2 into x minus 4. Now, x minus 4 is taken as a common, it becomes x plus 2 and x minus 4, that is equal to 0. The multiple of these two terms is equal to 0. Either x plus 2 is equal to 0 or x minus 4 is equal to 0. If x plus 2 is equal to 0, then x is equal to minus 2, because when you transpose 2, it becomes minus 2. And when x minus 4 is equal to 0, then x is equal to plus 4. Now, sum of zeros is equal to minus coefficient of x divided by coefficient of x square. Here we have the two zeros, that's minus 2 and plus 4. Take the sum of these two zeros, it's minus 2 plus 4, that is equal to minus. Coefficient of x is minus 2 and the coefficient of x square is 1. It becomes minus into minus 2 divided by 1. Minus 2 plus 4 is equal to plus 2 is equal to minus into minus is plus. 2 by 1 is also equal to 2. Now, product of zeros. Product of zeros is also equal to constant term divided by coefficient of x square. Here, when we product these two terms, it becomes 2, 4 or 8. Minus 8. That is equal to constant term is minus 8 divided by 1. That is equal to minus 8 is equal to minus 8. Part B. Part B. X square plus 2 under root 2x minus 6. Solution x square plus 2 under root 2x minus 6 is equal to 0. We have to split 2 into under root 2x. Here, x square plus 3x minus under root 2x is equal to 2 under root 2x. Minus, instead of 6, we can write under root 2 into 3 under root 2, because 3 into under root 2 into under root 2 becomes under root 2 plus square. That is equal to, then 3 into 2 is equal to 6. It's also equal to 6. Now, in x square plus 3 under root 2x, take x as a common. It becomes x into x plus 3 under root 2. Now, in these two terms, take root 2 as a common. Here, it is root 2 into x plus 3 under root 2, that is equal to 0. Now, x plus 3 under root 2 is a common. It becomes x plus 3 under root 2 into x minus root 2 is equal to 0. Either x plus 3 under root 2 is equal to 0 or x minus root 2 is equal to 0. If x plus 3 under root 2 is equal to 0, then x is equal to minus 3 under root 2. Here, x is equal to root 2. Now, we have two zeros, that's minus 3x root 2 and x is equal to root 2. Sum of zeros is equal to minus coefficient of x divided by coefficient of x square. Here, sum of zeros is equal to minus 3 under root 2 under root 2 is equal to minus coefficient of x is plus 2 under root 2x divided by coefficient of x square is 1. Here it becomes minus 2 under root 2, because when you subtract the 3 minus 3 under root 2 plus under root 2, it becomes minus 2 under root 2. 2 is equal to 2 under root 2 divided by 1 is equal to 2 under root 2, and here it is a minus, it becomes minus 2 under root 2. Now, product of zeros is equal to constant term divided by coefficient of x square. Here we have two zeros, that's minus 3 under root 2 into root 2. It becomes minus 6, because under root 2 into under root 2 becomes under root 2 plus square. That is called under root 2. Then minus 3 into 2 is equal to minus 6. Here constant term is minus. Find a quadratic polynomial, each with the given number or the sum and the product of zeros respectively. We know quadratic polynomial is equal to x square minus sum of zeros into x plus product of zeros. Part A, 1 by 4 comma minus 1. That means 1 by 4 is the sum of zeros and minus 1 is the product of zeros. We know quadratic polynomial is equal to x square minus sum of zeros into x plus product of zeros. Here sum of zeros is equal to 1 by 4 and product of zeros is equal to minus 1. Now use them in the general term. That's quadratic polynomial is equal to x square minus sum of zeros into x plus product of zeros. Therefore, quadratic polynomial becomes x square minus, instead of sum of zeros, you have to write down 1 by 4 into x plus, instead of product of zeros, you have to write down minus 1. It becomes x square minus 1 by 4 into x minus 1. Now, it becomes 4x square minus 1x minus 4. We take the 4 as LCM. Part B, root 2, comma 1 by 3. We know quadratic polynomial is equal to x square minus sum of zeros into x plus product of zeros. Here sum of zeros is equal to root 2 and product of zeros is equal to 1 by 3. Therefore quadratic polynomial becomes x square minus root 2x plus 1 by 3. That is equal to x square minus root 2x plus 1 by 3. That is equal to 3x square minus 3 under root 2x plus 1. Divide the polynomial p of x by the polynomial g of x and find the quotient and the remainder in each of the following cases. P of x is equal to x cubed minus 3x square plus 5x minus 3, and g of x is equal to x square minus 2. Solution. Here minus 2. Solution. Here p of x is equal to this one and g of x is equal to x square minus 2. Now x cubed minus 3x square plus 5x minus 3 is a dividend and x square minus 2 is a divisor. Now what we have to do? First term of dividend is x cubed and the first term of divisor is x square. What should be multiplied to the x square so that it becomes the x cube? That's x should be multiplied to the x square. But this x should be multiplied to the whole divisor. When you multiply into x square minus 2, it becomes x cube and minus 2x. Keep the degree to which it is aligned. Here, what we have to do? Now we have to change the signs. Minus becomes plus and plus becomes minus. Here it was x cube, it becomes minus. Here it was minus 2x, it becomes plus. Now x cube minus x cube will cancel each other. Minus 3x square will come down. 5x plus 2x becomes 7x and minus 3. Now again you have to continue the process. Now the first term of the dividend becomes minus 3x square and the first term of the divisor is x square. What should be multiplied to the x square so that it becomes minus 3x square? That's minus 3 should be multiplied to the x square minus 2. That becomes minus 3x square plus 6. Now change the signs. Minus becomes plus, becomes minus. Minus 3x square plus 3x square will cancel each other. Here it remains 7x. Minus 3 minus 6 both are negative. That is equal to minus 9. Hence our quotient is x minus 3 and remainder is 7x minus 9. Part B. P of x is equal to x raised to power 4 minus 3x square plus 4x plus 5 and g of x is equal to x square minus x plus 1. Solution. P of x is equal to x raised to power 4 minus 3x square plus 4x plus 5. G of x is equal to x square minus x plus 1. 3 is missing. We can write x raised to power 4 plus 0 into x raised to power 3 minus 3x square plus 4x plus 5. This is the dividend and our divisor is x square minus x plus 1. The process is same. Here the first term of the dividend is x raised to power 4 and the first term of divisor is x square. What should be multiplied to the x square so that it becomes x raised to power 4? Here x square should be multiplied to the x square minus x plus 1. It becomes x raised to power 4 x cube minus x cube plus x square. Keep the degrees to which it is aligned. Here now change the signs. Plus x raised to power 4 becomes minus. Minus x cube becomes plus. Plus x square becomes minus. Now x raised to power 4 and minus x raised to power 4 will cancel each other. Here plus 0 x raised to power 3 plus x raised to power 3, that is called x raised to power 3, minus 3x square minus x square. Both are minus, it becomes minus 4x square plus 4x plus 5. Now x should be multiplied to the x square minus x plus 1. It becomes x cube minus x square plus 1. Again change the signs. X square, x cube and minus x cube will cancel each other. Now minus 4x square plus x square becomes minus 3x square. Plus 4x minus 4x becomes plus 3x plus 5. Now multiple 3 to the divisor, it becomes 3x square minus 3x square plus 3x minus 3. Now change the signs, it becomes minus 3x square will become plus 3x becomes minus, plus 3 becomes minus 3. Now minus 3x square plus 3x square will cancel, 3x minus 3x, now it is plus 5 plus 3, that is equal to plus 8. Or quotient here it is. Thank you. Have a nice day.